You see, we are on router 7. Router 7 is one of the customer. Router 6 is also same customer, but remote office. So router 6 and 7 are same office, but in two different region. And you got one ISP in the middle. In reality, you will have many ISPs in the middle, but you are not in a service provider track, so don't need to think about that. If you understand one ISP, same story. Now, what I'm trying to say here is, we want to ping between the pink, which is in the right, this looks purple. Anyway, take it as pink. You want to ping between pink and blue. That's the name of the site. Right, I want to ping between these two. Before that, I want to show you the IP addresses. These two are on the pink side. And on router 6, these two are on the blue side. We want to ping between these two only. We don't really like to ping the ISPs 10.34.333. No, that's not our office. So we want only reachability between blue and pink. Okay. Now ISP is an autonomous system 3000. BGP. With the help of MPBGP layer 3 VPN and MPLS, ISP is going to form a tunnel between R1 and R5. Between what and what? R1 and R5. Exactly. They are provider edge routers. So there's going to be a tunnel between R1 and R5. And that tunnel is here. You need to build this tunnel. Right. So whatever that goes through the tunnel cannot be seen by the middle router, the in-between routers. Whatever goes through the tunnel cannot be seen by the routers like 2, 3, and 4. So blue customer's route will enter the tunnel. It will only get delivered in R5s, VRF, or pink. Pink and blue are same customer. Same customer. So why can't we make it as blue here also? No problem, nothing wrong. Blue, remote site. Remote blue. I name it as remote blue. So that you will not have that confusion. When I say remote blue, you know that it is the same customer. We'll check. We will check what has been configured. But what need to be configured, you already know. What need to be configured? Tell me. You need to have reachability between R1 and R5. And then you need to have MPLS. And then you need to have BGP. And then you need to have L3 VPN, isn't it? So we are going to do one by one if it is not there. R5, I would like to call it as P2. Provider edge. P1. So channel needs to be between P1 and P2. Okay, now between on R6, still I have not assigned this physical interface address. So let me do it. Interface Ethernet 00. 100, 100, 16, 6. All right. Listen carefully. I don't want ping between R6, R7 physical interface. I don't want. That's my that I don't want. I don't want when I ping from here 200, 200, 757.7, it should not ping. But when I ping from this address to this address, it should ping. You understand? I don't want, that's my policy. Only through BGP you can achieve this. No other protocols can do this for you. We'll talk about this after some time. But I just set the expectation with you. What is that? Loopback of R6 should ping loopback of R7. And none of the routers here should be able, they should not ping. None of the routers in the ISP should ping this. They should not ping this. Okay. Now, let me go to router 1. You see, you already got 10.12 and loopback. What you don't have is the customer facing interface. See, customer facing interface is still down. I want to come to that later. Let me check whether I'm able to ping router 5. I'm able to ping, which means I have OSPF. You see? So that answers your question, Bala. First question. What routing protocol you have? Next. Show IP BGP. I don't have BGP. Now, I want to know whether MPLS is there. Show MPLS forwarding table. Yes. MPLS is already there. And if you have not seen the previous class videos, if you see, you will know how this comes. So I'm not going to explain that MPLS part now because you already know it. Do you know it? This is not yesterday's class. This is long back class. Please go through it. Yeah, please go through the video. Now, sir, how about you? You were there in this class now when we were enabling MPLS? Okay, fine. So let me just try tracing the route to check whether MPLS labels comes into picture. They will. See, the label given by router 2 is used to go to router 2. And then Next level will maybe 302, okay, given by router 3. Next level will start at 400 and something. And then label will be popped because of PHP. See, 400. And then next up will be without label. No label. Fine. MPLS is working fine. So what is next is we need to build tunnel. For that, I need BGP. So what I do is I'm going to say router BGP autonomous system 3000 address family. You see L3 VPN v4 unicast neighbor 5.5.5.5 and you don't have remote AS command. Why? Because you need to first configure the neighbor. So I come out of the address family. I say neighbor is 5.5.5.5. Remote AS is 3000. To this remote AS, update source loopback 0. Do you follow me? Did you understand what I have done so far? Normal BGP configuration. Now, yes, yeah. So now I'll go to router 5. And I'll say hostname PE2, router BGP 2000, 3000. Let me pull this one up so that you understand. No, 3000. Neighbor, remote is 3000. Update source. Okay. Now you can see the neighbor is up. Show IPBGP summary. You see the neighbor is up. We are not interested in this neighbor. We want VPN. So what we need to do? See, show BGP VPN v4 unicast all summary shows nothing, which means there is no VPN. Let me create VPN now. Go back to BGP and say address family IPv4. Address family VPN v4 unicast. Don't forget. What command? Not IPv4, VPN v4. And then I say the neighbor which I already have activate as a VPN member. Do the same on the other side. Router BGP 3000. 3000. Address family VPN v4 unicast. Neighbor which I already configured. Activate. Now you will see VPN coming up. Okay, well, let's verify. The verification command is show BGP VPN v4 unicast summary. All summary. All means VPN always comes with VRF. So all VRF. It can be blue customer, tomorrow it can be another customer orange, another customer pink, another customer violet. So all customer. All means what? All VRF. Summary. You see, I have the VPN up for 41 seconds, 47 seconds. So VPN is also ready. VPN is ready. What is next? Next is we need to attach the VRF to this VPN. And then we have to establish the tunnel. We need to establish the neighbor between the customer edge and the provider edge. and learn the route from the customer, distribute it through the tunnel to the remote. How to do this is what our next task. Listen, I would like to go to the customer side and finish configuring BGP part. I'm on router 6, router BGP 1000, neighbor 100.100.16.1. This is what the address on P1, remote AS 300. And then 3000, sorry. Boom, 3000. And then I want to advertise the networks, mask, network, mask, done. Likewise, I'll go to router 7. Neighbor is 200.200.57.7. 5. Remote AS 3000. Network must. Say on the customer side, you should not create any VRF. No VRF configuration, no VPN configuration on the customer side. Normal BGP. Okay. So router 7 and 6 are ready to form neighbor, but who is not ready? PE1 and PE2 is not ready. Listen carefully. The interface of PE1 that connects to the customer should be kept in a separate routing table. For that, first I need to create the routing table. Right now, if you see here, show IP route VRF start. This is the command that will show all the routing table. You have never used this command before. You usually type what? Show IP route. That will show only the default routing table. Isn't it? This is default routing table. When I type show IP route VRF all, it will show all the routing table. The default, and if there is any other routing table. There is no other routing table. That's why it is not showing. You see, I will also use this command show IP VRF. You see nothing, which means we don't have any VRF created so far. We want one customer's route to be managed by a separate control plane. So we need a routing table for the customer. So I'm going to create it like this. Are you ready to see the configuration of VRF? This is it. IP VRF forwarding, or IP VRF, no need. IP VRF, given name, CE-blue, any name. Route distinguisher, I'm going to give 1:1. This is the unique identification for that routing table which I'm creating. And route target, as I said, that is to identify which route to give to whom. So I say export, I'm going to export with 1:1. I told you it is a 64-bit value, you see. You can type 32-bit autonomous system number and 32-bit IP address number or some number. It's your wish. I'm just going to say one point one. I want to tell you something. This route distinguisher and route target doesn't need to match. Because this is a lab environment, I do not want any confusion, so I am taking the privilege of using the same number so that I won't have a confusion. Not only export, even the import also I'm going to use the same number. When we do this lab tomorrow, we will make it a little bit complicated by a different number. As of now, let's keep it simple. Next, you see, yeah, 64 bit, all are 64. Show IPVRF. You see, I have created a VRF called C blue, and its identification number is this, but there is no interface assigned. This is the interface E01 need to be assigned. So I'm going to assign it. Listen carefully. You have to first assign the interface to the VRF and then assign the IP address. If I assign IP address first and then the VRF, the problem is when you assign the IP address now, it will go to the default routing table. So when you create another VRF and put this interface, then the routing table will throw from the default and join in this. So first join the interface to the created VRF. This is the VRF you created, right? So you say IP VRF forwarding and then put the IP address. IP address is 100.100.16.1. Now, how do we verify? Ping and see. If you simply ping 100.100.16.6, which is customer blue, it won't ping. Can someone say why? Why? By default, when you ping without VRF, it will use the default routing table. In default routing table, we don't have this route. You see, show IP route. In default routing table, you don't have 100. Where do you have? You have in VRF. Here only you have 100. This is another routing table. If you want to see all the routing table, as I said earlier, you need to say show IP route star. So you see first you see the global routing table and you see the blue routing table. So you need to say ping using VRF 100.100.16.6. Now it will ping. Listen, it's pinging. What is next? Next is we need to form neighbor, BGP neighbor. For that, router BGP 3000. Now listen carefully. Address family, not VPN. VPN is already configured. Now you say IPv4, VRF this customer. For this customer, so you are getting into the routing table of that customer. You're going to the control plane of that customer and say form neighbor 100, 100, 16, 6. Remote AS 1000. Now you will see neighbor coming up. See, the neighbor has come up via this control plane, via this VPN control plane. Okay, now let us check the routing table. I should see the routes in the BGP routing table. You see, I have, let me finish. I have learned the route from blue into its specific routing table. Your question, please. No, no MPLS, no VRF, nothing in R6. R6, as I said earlier, if you go back in the video, if you rewind this video and see, I have told in a few minutes back, R6 and R7 will not be aware of any VPN, VRF, MPLS, nothing. Simple, plain, normal BGP configuration. I have used the word normal BGP configuration. Okay. Now what is next? I want to go to routers 5 and repeat the similar configuration. Okay, now where are we? Here. IPVRF. You can give any name. There I gave customer blue. Here I can give customer remote blue. If you want to give same name also, okay. Route distinguisher, what I gave there? 1:1. It is not mandatory to be same here because it is for the router to differentiate from one routing table to another. This route distinguisher is local. So here I can give triple two colon triple two also, nothing wrong. If you keep same also okay, different also okay. But what should be same is the route target. Import should be 1:1 because I exported from there 1:1. And there I import 1:1, so I need to export here 1:1. Now we need to go to interface Ethernet 00 IP address. No, first you allocate the interface to the VRF. What's the VRF name? This one. IP VRF forwarding. And now you put the IP address 200, 200, 2. And now you go under router BGP 3000. Address family IPv4 VRF, and the VRF name is this. Neighbor 200, 200. Do you follow? 2000. Now we will see neighbor coming up. If not, we need to troubleshoot. Show IP VRF. Interface. I have given wrong interface. Oh my god, look at this. Now I have spoiled the OSPF. Default interface Ethernet 0/0. Okay. Now, interface Ethernet 0/0. IP address is what? 10.45.0.5. 255. Okay. Oh no. Okay. I made something wrong. Okay, OSPF is running on this. Okay, I think area is 100. That is why. You see, I have written here in the top area 100. Now the neighborship will come. Okay, the MPLS will also come. And BGP also will come. VPN will also come. Okay, now let me check whether VPN has got the roots. Show BGP VPN v4 unicast all. Yeah, you see The route from head office blue is coming to PE2. That's a good news. Now let me go to interface Ethernet 0/1. IPVRF forwarding. This is the name. And the IP address 200.257.5. Now you go router BGP 3000. Okay, neighbor has come now. Okay, all is well. Now I should go to router 7 and check whether I'm learning the route. You will definitely learn because I have done this 100 times at least. Show IP route. Look at this. I'm able to see the IP address of the remote office, but not 100 because I have not advertised 100. I advertised only 6.6 and 66. So if I ping from here, I should be able to ping from 777 source. Look at this. Trace route. Okay, it has gone to the gateway, which is router 5, and then it takes the VPN. Now, this is the VPN label, the tunnel label. And this will never change. You see, it's not changing. This will change hop by hop. This will have the bottom of a stack bit 1. This will have bottom of a stack bit 0. All right, this will get removed now, but this won't get removed. This will get removed only after reaching router 1. You see? It reached router 1. Now it will be removed and sent to router 6. All right. I would like to stop here. More explanation, we'll do it in our next class. But you try doing this. When you do this, you will face some real challenges, which will give you good learning. And afterwards, when you come to next class, you will understand these things better.